Good morning, friends. Today we'll cover problem number 4 in our tutorial series on top Java coding problems. So this problem 4 is regarding stacks. A stack is a linear data structure that follows the LIFO, which is last in, first out principle. That means the objects can be inserted or removed only at one end of it, also called a top. Last object inserted will be the first object to get. So if you look at this diagram, I think stack is a very common data structure. So whenever we push any entry, any object into the stack, so there is a top pointer which will be always pointing to the top of the stack. For example, if I'm pushing this C object inside this stack, you can say, so the top will be updated to the latest C. And whenever we pop means that we are taking any element. So always the element which is pointed by the top, that would be taken out. So for example, top is pointing to C, so that will be taken out and returned. And then top will move down to the next element, which is in the stack. So this is what a stack data structure is. I think most of you must be aware of it. So in this problem, what we have to do is that we have to implement a stack in Java without using any standard Java collections. So what it means is that because in java.util, I think we already have a stack already implemented in Java API. We don't have to use that, of course. So that's the problem statement. And we also have got an interface called a StackI, in which we have defined a generic StackI T, element T. And when we pop, this T element would be returned. And when we push, we can push this item. And in the peak, this is a third method. So the difference between pop and peak is that when we take pop, so the pop will actually remove this element from the top, and the top has to move down. But for the peak, this element should not be removed. Only this, whatever the value is there, only this is returned back without taking it out from the stack. So this is what peak does. So this is the first implementation without using any standard Java collections. After this, we will have a follow-up that we have to use the Java collections. So this is for the knowledge of that how much API that you know about Java. If you tell the interviewer that you know about stack class, which is already available in Java API, which is a good impression to them. So in the follow-up one, we have to use that and show and implement this StackI interface. The next follow-up would be to implement a bounded concurrent stack in Java using locks. So bounded concurrent stack means that we will have a stack with a capacity, and whenever the capacity is hit, and when any thread tries to push some more data exceeding that capacity, then it should be waiting. And whenever any element is pulled out, which is popped, then the thread should proceed. So somehow we have to maintain a waiting condition that whenever we push or pop, we have to check whether it has hit the capacity or if the stack is empty. And in follow-up 2, we have to do it using locks. And in follow-up 3, we have to do the same thing using SAS operation. SAS operation is compare and swap operation, which is provided by atomic classes in Java. So guys, this was all about the problem statement. Again, I would suggest very strongly that you should try the problem on your own. We try writing some code and write some unit test cases to do this problem. In the next video, we'll go through the solution. So see you all in the next video.